The title of our notes today are Graphing Nonlinear Functions, and we talked about the definition of linear and nonlinear. Linear function meaning that it's a straight line, and nonlinear meaning that it's not a straight line. So today we're going to be graphing some of these nonlinear functions using a table. So if you open up, we've got example number 1, asks us to graph y equals x squared. And what they've done is they've already given us x values. They've given us what we call domain values. The x values are always domain values. And we're just going to plug those x values into our equation inside parentheses to find out what our output or what our y values are. We also sometimes call this domain and range. The y values can be called the range values, which can get a little confusing because we talked about mean, median, mode, and range. This is a different kind of range. These are range values where the y is. So domain and range, sometimes the y is called a range. Anyway, if x is -3, then the quantity -3 squared for x squared, -3 times -3. If the negative is inside parentheses, we include it when we square it. Negative times a negative is a positive. 3 times 3 is 9. And so my ordered pair here, x is -3, then y is 9, so -3, 9. If x is -2, we're going to say then the quantity -2 squared. If the negative is inside parentheses, we include it when we square. Negative times a negative is a positive. 2 times 2 is 4. So when x is -2, y is 4. The quantity -1 squared. A negative times a negative is a positive. 1 times 1 is positive 1. So when x is -1, y is 1. Our ordered pair is -1, 1. If x is 0, we have 0 squared. 0 times 0 is just 0. So when x is 0, y is 0. Our ordered pair is 0, 0. If x is 1, 1 to the second power, don't get confused. Don't say 1 times 2. Make sure this is 1 times 1. 1 times 1 is 1, so when x is 1, y is 1. 2 squared, 2 times 2 is 4, so the next ordered pair is 2, 4. And then 3 squared is 9, so my last ordered pair is 3, 9. And now we're just going to graph those points on our coordinate plane system over here. So we've got -3, 9. We've got -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So if you need to take a second, you can. Take a second, get those plotted. This top line or this top dot should not be on my ordered pair here. And then we just connect them with a curved line. Remember that these are nonlinear functions, so we won't be using a ruler today because a ruler won't help us. These are curved lines. They do not form a line. Once we graph, make sure that our arrows come all the way off of our coordinate plane system. We can label our points, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And then we can label our line at one of these arrows, y equals x squared. And we've graphed our nonlinear function by using a table. So we plugged in values. We found our x, y coordinates. We graphed our x, y coordinates and connected them with as neat of a line as we could. This is what we call a parabola when we have an x squared U shape. X squared always gives us a U shape parabola. Sometimes it's U shaped, sometimes it's upside down U. I labeled my points on this graph. I extended my arrows past the coordinate plane. And now I've graphed example 1, y equals x squared. It is a nonlinear function because the points do not fall in a line.